Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the binary star. Actually, in the complete universe, all the system in which one planet is revolving around the other one, which is called a sun, the system is binary star in which there are two objects or two heavenly bodies which are rotating about their common center of mass. In fact, it is believed that Earth and Sun are also rotating about their common center of mass, although that common center of mass lies inside the Sun itself, because Sun is almost 100 times heavier or than the Earth. Therefore, we can say that that common center of mass of Earth and Sun system almost lies inside the Sun. Therefore, Sun never seems to be rotating about that common center of mass. So this is a binary star in which there are two masses which are rotating about their common center of mass, and you can see that there is a force of gravitational force which is acting on this one F1, and force F2 is acting on this one. This force is being balanced by MR1. This is M1R1 omega 1 square, and this force is being balanced by M2R2 omega 2 square. So first of all, we know that F1 is equal to GM1 into M. Now this M is the center of mass of the system. So we know that this force would be, this force F1 is force on M1 due to M2, and this force F2 is force on M2 due to M1, which would be equal obviously. So it would be M1 M2 by this distance, complete distance is R1 plus R2 ka whole square. Or we can also term it as d square. So because we are assuming that R1 plus R2 is d. Okay, now we know that F2 is also same, which is G M1 M2 by d square. So G M1 M2 by d square is equal to M1, and this is R1 omega 1 square, and cancelling this M1 with M1, so G, this is G M2 by R1 d square is equal to omega 1 square, and hence here it would be G M1 M2 by d square, that would be balancing M2 R2 omega 2 square. Cancelling this M2 with M2, omega 2 square will be equal to G M1 by R2 d square. Okay, so now we what we will do, we will replace the value of R1 and R2, and we know already that R1 is equal to, R1 is the distance of mass M1 from the center of mass. So we already know that R1 will be equal to M2 d upon M1 plus M2, and R2 will be equal to M1 d upon M1 plus M2. Okay, so let us substitute these values in this term. Now we know that F is this omega 1 square is equal to GM2 by R1 d square. Omega 1 square is equal to GM2 by R1 d square, and R1 is equal to M2 d upon M1 plus M2. So omega 1 square is equal to G M1 plus M2 upon, you can see, d cube. Okay, and similarly we know that omega 2 square is equal to G M1 upon R2 d square, where R2 is equal to M1 d upon M1 plus M2, and omega 2 square will be equal to G m1 upon R2 is m1 d cube upon m1 plus m2. So cancelling out this, we will get that omega 1 will be equal to omega 2, and omega will be, this is omega, and omega will be equal to under root of G into m1 plus m2 by d cube, and this is 2 pi by t. So we could also find out the time period. So this is the time period of rotation of each planet around the center of mass, and this leads us to a conclusion that each of the planet has same angular velocity about the center of mass, and therefore each of them would always be in front of each other on this line always. Now let us see that what is the kinetic energy of the system. So the kinetic energy of the system is half m1 into r1 square into omega 1 square, and the kinetic energy of the other one is half m2 into r2 square into omega 2 square. So the total kinetic energy of the system is half is common, and this is m1. Now r1 square, we know that r1 square would be m2 square by m1 plus m2 whole square, and we know that omega is same, so this is omega square plus this is m2, and r2 square will be m1 square by m1 plus m2 whole square into omega square. So kinetic energy will be equal to half m1 m2 upon m1 plus m2 whole square omega square into m1 plus m2, and cancelling out this m1 plus m2, so kinetic energy will be equal to half m1 m2 omega square by m1 plus m2. This term is called as reduced mass. It is called as reduced mass due to the fact that this mass would be less than the mass of the greater mass of this m1 and m2. So that is why it is called as reduced mass, and it is denoted by mu. So kinetic energy will be half of mu into omega square. Now let us discuss the angular momentum. So the angular momentum total of the system will be equal to I1 omega 1 plus I2 omega 2, and this this omega is same, so I1 plus I2 into omega, and I1 is m1 r1 square and I2 is m2 r2 square, and this is omega square. So by substituting the values of that r1 and r2, first of all we have also substituted the values of the r1 and r2 in terms of m1 and m2, and there would be a d square also in this term. This is d square also because we have substituted the value of r1 and r2. So here would be a d square, so this is d square and this is d square. Okay, so this is the kinetic energy, okay, with d square. So now if we will substitute the value of r1 and r2 here, then it would be r1 is m2d by m1 plus m2 square, and this is m2 into m1 d by m1 plus m2 square into this is omega, not omega square. Okay, now let us take out common terms, and you can see that the common terms are m1 m2 d square and omega square, in fact omega. So it would be, and in the denominator it would be m1 plus m2, and here there would be m1 plus m2 and cancelling this m1 and m1 plus m2 with this one, so we can see that the angular momentum of the system L of binary star, or I can write down it as binary star, will be equal to, this is m1 m2 by m1 plus m2 into mu, in fact into this omega into d square. So this is mu d square into omega, angular momentum of binary star. And if they are rotating in anti-clockwise sense, then this angular momentum would be out of the plane. And if they are rotating in clockwise sense, then this angular momentum would be inside the plane. So this was the binary star system, and you can use the term of reduced mass mu instead of the mass of complete system, and you can find out the angular momentum and kinetic energies. Thank you.